Hi guys, let us continue on tutorial part 3 on chapter 1, Matter. We continue on subtopic 1.4, Physical and Chemical Changes, Kinetic Molecular Theory of Matter at Low Temperature and Kinetic Molecular Theory of Matter at High Temperature. Physical and chemical changes. Physical change, an alteration of a substance that does not change its chemical composition. No new substances are formed when the state of substance change, and a change of substance state is interconvertible. During a change of state, the temperature will always remain constant. For kinetic molecular theory of matter at low temperature, it shows that when heat is removed, particles are cool. It loses energy. Thus, its kinetic energy decreases, and the particle move or vibrate more slowly as at low temperature. When the particle loses a certain amount of kinetic energy, it cannot overcome the intermolecular forces between them, and particles are difficult to move freely, and it will arrange and confine themselves in fixed position. Therefore, particles change its phase. Whereas for kinetic molecular theory of matter at high temperature, when heat is supplied or particles are heated, it absorbs and gains energy, and thus its kinetic energy increases. Particles are moved or vibrate faster energetically. When the particle have enough or sufficient kinetic energy, it can overcome the intermolecular forces between them. Particles move freely, and it will no longer arrange or confine in a fixed position. Therefore, particles change its phase. Let's look at change state of matter. Freezing, melting, sublimation, deposition, vaporization, and condensation. Change state of matter. Freezing, liquid to solid phase. When heat from a liquid is removed, that is, liquid is cool, particles slow down. Kinetic energy drops until particles can no longer overcome the attractive forces, and particles arrange into fixed position to become solid. Melting, solid to liquid phase. When a solid absorbs heat, that means solid is heated, particles vibrate faster. When the kinetic energy of the particle is strong enough to overcome the attractive forces, particles move freely and are no longer confined to fixed position. Thus, solid converts to liquid. Sublimation, solid to vapor phase, occurs when molecules on the surface of a solid possess enough kinetic energy to overcome the attractive forces, leave the solid phase as a vapor. Deposition, that means vapor to solid phase. When cool under certain conditions, vapor molecules lose kinetic energy and can no longer overcome the attractive forces. Thus, molecules arrange into fixed position to become solid. Vaporization, liquid to gas phase. When a liquid absorbs heat, liquid is heated. The particles in the liquid move faster. A few particles at the surface have enough kinetic energy to escape as a gas. Condensation, gas to liquid phase. When a gas is cool, the particles lose energy. They move more slowly. When they collide with each other, they do not have enough energy to bounce away again. They stay close together to form a liquid. Let's look at a diagram of a change of state. Melting, that is from solid to liquid. Freezing, that is liquid to solid. vaporization, that is liquid to gas, and condensation, that is gas to liquid, sublimation from solid to gas, and deposition as gas to solid. Let us look deeper on chemical change. A chemical changes occur when a substance combines with another to form a new substance. A formation of a new substance through a chemical reaction. And also the examples on chemical changes is neutralization and combustion. These are few examples of the chemical formula for neutralization and combustion. And now let us see the comparison of physical change and chemical change. Now let us do practice 1.4 together. Given the diagram of physical change of solid, liquid and gas, name the process A, B, C, D, E and F as below. A. Sublimation, B. Melting, C. Vaporization, D. Deposition, E. Freezing and F. Condensation. Okay guys, this is the end of the slide. Remember to do the exercise. Thank you for watching this video.